we want to do an example of a hyperboloid of one sheet here. We have this equation in front of us and it just says sketch. So to determine whether or not we're dealing with a hyperboloid, we look at each term and we realize that one of these terms has a negative on it and they're all degree 2. So by doing that, we know we have a hyperboloid of one sheet. So that should give you some guidance on what the final result is going to look like. But this isn't really in the standard form, so let's do a little bit of algebra to get it in the standard form. So remember that a hyperboloid is going to have a 1 here. So we have to divide everything by 4. So we have 4x squared minus y squared over 4 plus 4z squared equals 1. But that's still not quite in the right form. So we're going to write that as x squared over 1/4 minus y squared over 4 plus z squared over 1/4 equals 1. And then we have to get that. There's one last step. We have to make this something squared. So that's x squared over 1/2 squared minus y squared over 2 squared plus z squared over 1/2 squared equals 1. So that's how we get the standard form. So if we want to look in the xy plane, we'll think about z being 0 here. And what we have is a hyperbola where you have something of the form, well, you have this equal to 1. So if you remember how to graph hyperbolas, the easiest way to do that is to sketch these exit points here and kind of construct a box, and the asymptotes will go through that box. So I'll show you what I mean. So x has this negative 1/2. So so that tells me x is here, negative half and positive half. And y has a 2, so that tells me y is positive 2, negative 2. So if I have some sort of box that contains that, then you can also determine the values. You can determine the values where they strike the axis. So if you say, oh, well, if x is equal to 0, well, y can't be anything because that wouldn't be able to be equal to 1. So you know that you don't have a hyperbola that goes, you don't have a hyperbola that strikes where x is equal to 0. So it doesn't strike here. It has to strike where y is equal to 0. So it always strikes where the positive, or it works in the case of the positive case. So if y was also 0, then x would have to be that 1/2 here. So you'd have, well, if I can do it right, you have your asymptotes go through the corners of the box. And your hyperbolas strike that point and they sort of ride the asymptotes. And again, it's not perfect. I was reaching a little high, but that's the idea. That's the hyperbola in the xy plane. So when we think about this particular case, we would say that the y value can go -2 to +2, x -1/2 to +1/2. and your hyperbola so that's your xy plane projection. Now, if we look at the xz plane, so if y is equal to 0, well, in that particular case, that's actually a circle. So notice that in the case where y equals 0, x squared plus z squared equals 1/2 squared. So we have a circle in the xz plane that only goes out to -1/2, or from -1/2 to +1/2. So you actually have a pretty small circle there for y equals 0. So again, in the case where y equals 0, you'd have that little circle. But that may not be the whole story, because what happens as y gets larger? Well, as y gets larger, if y is a positive number or negative, it doesn't matter, then we would add that over. So in the case of like y equals 1, you'd have x squared plus z squared equals, well, they're all over 1/2 squared, equals 1 plus, actually in this case, let's make y equal to 2, right? Because that makes everything cancel. So that 1 plus 1. So then that makes x squared over 1/2 squared plus z squared over 1/2 squared equal 2. And then if you multiply that across, you end up with x squared plus z squared equals, well, that's really just 1/4. So if I multiply both sides by 1/4, I get 1/2. Or might be easier to write it as 1 over square root of 2 squared. So by doing that, what we find is if we move out to here, we now still have a circle. So what you're going to find is at each point on y, you're going to have these circles coming out. You're going to have these circles coming out here. So it's kind of like a horn, right? Now in the YZ plane, that's going to be the idea where x is 0. So if x is 0, in this particular case, what you have is you still have a hyperbola. You still have a hyperbola. You're actually going to have a very similar hyperbola to what you have here. It's going to be it's the same hyperbola. So to graph that, you have the same idea, the same hyperbola here. So in the YZ plane, you're going to have the same idea. It's going to come up to that half mark, half mark. You have that same bounding box. And so your hyperbola it's still going to strike these circles, right? They all have this. If this circle's valid, it's still going to go through these circles, up, through those circles. So what you're going to have, and in a lot of case, in this particular case, I actually think it makes it worse plotting the Z1 here, because this captures it pretty well about what you're going to see. You're going to see circles that kind of form a horn, and you're going to see the hyperbolas in the YZ plane. You're going to see hyperbolas in the XY plane, and the circles in the XZ plane. And that's a hyperboloid of one sheet.